Well, hello, and this is the practical solution for problem 4. Yeah, let's jump right in. This is what I gave to you. It's in the textbook. It's one of the applications. And here we have a 12-volt battery or source. We have this resistor 1, resistor 2, which is a variable resistor, which is 3, and then an unknown resistor we want to test. So, to do that, we wire the circuit like this, and we have a galvanometer, or something that indicates current, in between these two branches. And if we adjust this meter till it reads 0 amps, then we can work out what this resistor is.
Hello.
And here,
So this is the experiment I set up for
the example.
The galvanometer. So here, so I don't have really good graphics or something. Is this circuit we're trying to build with the power source, two known resistors, our variable resistor, and the resistor we are testing for. Okay. So here we have the probes of my ammeter, which is standing in for my galvanometer. This is my battery connection. This black thing here is my variable resistor. These two resistors are my known resistors, and that is my unknown resistor, one which I'm planning for. So what we're doing is switching on the power from my battery and then checking the reading on my ammeter. So let's do that now. So I have current running through my ammeter, meaning that the branches aren't balanced yet. So now I have to balance it. So there's a little screw in there that I twist it the wrong way. I have to get it as close to 0 as I can. And this is actually quite hard because I've shot past it a couple of times. That's close enough to 0 for me. So I fiddled around with it and it goes to 0 there. So now what we have to do is I switch off the power because there's no current going. So it's balanced. Now I have to check my variable resistor. Switch over the probes. And then, so switch over the probes. Then I just check my variable resistor resistance 45.1. Okay, and that is the experiment.
Okay, so that was the experiment. So the reading I got was roughly 45.1 ohms, but at other times I got 45.7. Once again, gold band resistors not really that accurate, but I asked you guys to use 45.7, so this is the value we use going forward. So R1 is 1500, R2 is 3300, and R3 we've chosen now as 45.7. Type equation here, so that's obviously wrong. So this is the equation we're using. Rx equals R3 over R1 times R2. Plug in our values and we get the value of Rx is 100.54 ohms. And this is exactly the resistor value I used. I used a 100 ohm resistor. So everything worked out perfectly. But why did it work is the second part of the question. So we use this formula, and if we rearrange it, take R3 to this side, divide by R3, Rx divided by R3, Rx divided by R3 is equal to R1 divided by R2. So these two parallel branches have to be the same, or the relationship between them has to be the same. So what does that mean for our equations? Well, that means roughly that if I work out the voltages, because this is a parallel branch and this is the parallel branch, this is not a connection, just measures. When this is adjusted to read 0 current, there's no current flowing through here, so these are totally two parallel branches. So I have 12 volts here, so this will be 12 volts, this branch, and this will be 12 volt on this branch. So then I can work out with voltage division what these are, the value for, let's say, over this variable resistor, and I worked it out as 0.355 volts. Because this resistor is 1500, it's going to be a lot more voltage than my 45.7 ohm resistor here. And I did the same for this branch, and I also came up with the answer for roughly 0.355 volts. So these two voltages are the same. So I measured the voltage from here to ground, I get this. If I measure from there to ground, I get this. So this then means that there's no potential difference between these 2 points. So if I measure the voltage here, it will also be 0. So this means that there won't flow any current. There's no potential difference. So the difference in voltage here is 0. So no current will flow. And if no current flows, then we have two very parallel branches, and then we can use our equation to work out the resistance value for R4. Alright?